So have you all done that? Just scroll down on where we were in this page. You will get so we've all generated the key, right? The private key. So we tell it wherever place, except for the final folder, right? And we've also gotten our public key. Are we all done with that? Are we done with that? We generated a private key and we access the full region and you can see a public key. Your public key is click on put region. Okay. Click on put region. Then at the top there is a key. Then public key for pressing to open the SSH authorized keys file. Very long generated key. Can you see that? Yes. So now that is the public key that you're going to put in your authorized keys folder. So do not copy right now. What you're going to do, go back to your terminal, right? Where you're logged in. Then continue with step 6. This is step 6. On your secure node. This is step 6. Now continue with step 6 on your secure node. So copy paste the node directory, alright? SKDIR, SSH dash. So basically you're supposed to make a SSH directory inside there, whereby you're going to store your public key. So copy paste that SKDIR. After that, you're going to create a file authorized underscore keys by using the nano command. Okay. Nano, that should open up a black window. That's like the text where you're going to copy paste now the public key. After that, go back to Google. Copy paste the public key. Utawe hapo na hiyo authorized key file ilikuwa open na nano. Sawa. Then you control X and then you save. So, Peter?
Yes.
So you said if the file already exists, what do they do? /p or something p. You had mentioned something of the sort.
This was just, no, it was just a comment because in the guide it doesn't say this, but there should be a -p here, but it doesn't matter. It doesn't make any difference. This is not an important step. If you've just done this once, then it's enough. Yeah.
Because for one of the students, it says that the file already exists.
Yeah, so that's what happens if you've already done it once. So then you don't need to do it again.
Okay, so you just need to create the...
Just go to this bit. Just go to the next part, which is the nano, this bit.
Then we are done. We've not done. Who has not done so? All right, Peter, we can continue. Hello, Peter.
Yeah. Yeah, I've just realized because of the way that this is set up, we may actually have to skip the rest of this because it won't be possible to log in properly because all of these nodes are set up on IPv6. So it's going to be a problem to get back in. You'll have to come. I mean, you can't log in with a key from here. Is the problem? Okay. So if they've already skipped ahead, then they may actually be logged out already, which would be a problem. I suggest we just continue in this one. The basic idea is that we lock it and we go back, that we come back in again and use the certificate to actually get back in. But I think this is not going to work. I just tested it and I can't get back in from the local machine.
So what happens?
I think we just skip across to part 5 rather than go ahead with the rest of this here. When you're at home, you can do this and you're setting up your own node. It will make sense, but the problem is that the university doesn't have IPv6, so it's not possible to log directly into these machines.
All right, so you will skip the rest of the step to step 5.
I mean, we can walk through it and talk about it, but in general, yeah, I think we just we skip past this. I mean, the basic idea is that we set, for example, that the root cannot log into the system. We set that password authentication is disabled, yeah, and we also disable the challenge response authentication. So basically, we make it so that you can only log in with your key.
Okay, so. Okay.
But we skip to part 5. I think is the easiest.
Okay, so
also, I think we're running out of time, right?
So you have to skip the rest of part 4 because it's being configured in IPv6 and the university is under IPv4. And once you complete that step, you will be locked out. You will be able to access our node. Okay. So you have to skip that loop and go to step 5. So click on step 5 on the bottom. The idea was to secure your node. Okay.
Yeah.
Peter?
Yeah. If anybody's locked out, we can unlock them. It's not a problem.
So probably if you could explain to them what we were trying to do.
Okay.
Just a brief from the top to the bottom on securing the node.
I mean, this is a relatively new part. Most people in the previous guide, there was none of this stuff, but it's really important for an internet server. So basically what the concept is, if you can imagine, you have your house and the only thing that you need to get into your house is you walk up to the door and you say some magic words and the door opens, yeah? Now, if somebody's around you, they can hear you saying those words. So you're typing it in on your keyboard, and they can see your keyboard, or there's a keylogger or something like this. Then they can get straight into your house, in this case, into your server. So the concept is that instead of doing it like this, first of all, you give yourself a key, and you also have a password for it as well. So even if the person gets your password, they still need your key to get into the house or into the server. And I mean, for a local machine which is not connected to the internet, this is not a big deal because yeah, the people would have to physically be in front of the machine. But for a server like this, which is going to be on the internet, you want to have a key and a password so that it's not possible for people to compromise your system. So basically, the first step that we're doing here is we're generating a very random key, and it's a very long key as well. This is the number of bits that are in the key, and essentially a 2048-bit RSA key will take, I don't know, 100,000 years with current technology to break, just even a single key. So it's certainly possible, but it's unlikely that somebody's targeting you to that level. We're adding a password so that we have that double security, and then we're copying the key, the public part of the key, which is the equivalent of the lock essentially, to the server, and then we're saying to the server as we come further down, we're saying to the server down here, wherever we are. So then we're setting up PuTTY to use the key in this part, and then here we're telling the server to not let root to log in, so only normal users can log in, unprivileged users. And then we're saying also that don't just allow the use of the words, the password. Disable that and only allow keys to come in, keys and passwords in this case, together. And the same here. So it's the same thing. It's just disabling. In fact, generally you just need to disable this one. So that's basically what we're doing. And then the last part of this is just to restart the SSH server. Yeah. The problem being is that IPv4 is very expensive, so I don't have IPv4s for all of the nodes in the test session. As I was saying earlier yesterday, IPv4 there are no more. Yeah, they've all been sold. They all are owned by somebody across the world. We knew this was going to happen many years ago, and nobody really did anything about it. And so the whole world is addicted to using IPv4. And the reality is there are already too many machines. I think something like somewhere about 87% of all IPv4s are actually in use at any given time. So a couple of, like 10 years ago, they decided to move to IPv6, and that's what all of my nodes use because they're basically free. There are more IPv6 addresses than there are atoms in the known universe. So it's almost impossible that we'll ever run out of these. So that these nodes are set up that way. It's cheap, and for this reason, it's not. But unfortunately, the university doesn't have IPv6 set up. This could be something that they would look at. You can do it for free. Actually, you can get public IPv6 tunneled over IPv4. But in this case, we don't have this possibility. Right.
All right. Yes. You have another question? Yeah. So Peter,
Yeah.
the question is, so what's the worst thing that could happen if somebody gets access to your node, to your secure node?
I mean,
Can they transfer?
The simplest, they can't. I mean, they can't steal your Zen. I mean, there's a small amount of Zen on the node itself, but this is like worth a couple of cents. It's really not worth it. The big value for any internet-enabled server is a botnet. Yeah. So this is what happens to servers all the time when they're only secured with passwords, is that people will just run thousands and thousands of guesses of the password against the machine until they get the right password, user and password combination. And once they have that, they can get in and they can use that machine as part of a botnet to attack, to do DDoS attacks against large networks, or just generally, again, to enlist those machines to try and crack into other machines and make the botnet bigger. Yeah, you may have private information or websites on a VPS. And if you have a website on a VPS, then the attacker can come in and put some JavaScript onto the website page that hacks other machines, that other people who are visiting your website, for example. So it's really super important to secure internet-enabled servers against basically becoming part of botnet, and just generally against preventing people to come in and stealing information that you maybe don't want to have public or stolen by anybody. So yeah, this is the basic reason. Yeah.
Are we all good? All right. So Peter, we can continue to part 5.
Okay.
And before we continue, there is node 12.
Yep.
I think the user has been locked out, so probably we can check it.
Yeah, we can fix this. So
guys, we're going to start 5, right?
Okay. I don't know how you're logged out because this one hasn't been changed. Somewhere. How are they locked out? Because save this it on is the not desktop. locked. This one is not locked.
Alright, so it's okay. I think it's his computer which has lost connection. It's alright.
Okay.
So just continue. And we shall be breaking for lunch in 15 minutes.
Okay.
So,
Let me just have a quick look through part 5 and see where we can get up to, I think. Okay.
And lunch
So,
for an hour.
Okay, sure. Okay, well, part 5 is very simple. Basically, in part 5, we're just setting up a firewall. So, again, more extra security. The concept is that, in general, you should only open the ports on your system that are required for the services that you are running. Yeah, it's a basic principle of internet security, or in general, even on your home systems, on your firewalls and so on. You should be locking all ports down except for the ones that you're actually using. Yeah. You never know what's going to happen if you have some sort of, I don't know, an internet-enabled web camera or whatever on at home. And you only are expecting that it can be used on your local network. If that camera has a port that can be connected to, if you have that open to the internet, as we've seen, there's websites about this all over the place, where people have web-enabled IP cameras, and you can spy on people, basically, because people have not done this. So the basic concept is we only need a few ports to be open. HTTP, HTTPS, and SSH that we're currently connected. The HTTP and HTTPS is for the cert certification, so the creation of the certificate. So basically what we're going to do is we're first going to install this application called UFW, which is, what is it called? Something or other. It stands for Ultra Firewall or something like this.
It's uncomplicated firewall.
Uncomplicated firewall. There you go. So we're just going to, again, copy the command, press enter, or copy and then enter. Probably need to do your sudo password again. It probably will say that UFW is already installed. Yeah. And then we're just going to copy this whole block and paste it in here. So just right click. And the last one, you'll just need to press enter. Oh no, there you go. It's already done. So it's been enabled, and now we have the status, and it will show, if you click enter, then it will show you that the rules that we just put in have been set. And the final part of this, once that's all done, again, just copy and paste, is to enable it such that the firewall will restart whenever you reboot the server. What have we got here? Okay. Andrew, I would suggest before we move on that we stop there, because the next part is quite long and a little bit involved.
Okay, no worries. So before we go for lunch, I want all of us to have gotten there.
Yeah.
Yeah. So tukifika hapo tafadhali, tukishafika tunaenda lunch. So Arno, Peter, Hugh, we will be breaking for lunch for the next 1 hour. So let's be back at latest 2 p.m. Kenyan time, latest. But we'll be back at 1:50 p.m.
Okay.
So that's East Africa time, 1:50 p.m. Latest 2 p.m.
Paul, you are still then there?
I'm still here, yeah.
Okay, cool. Because I have to leave.
Yeah,
So
I'll just put an update on Discord and see if either myself or Peter will run that part of the session.
okay, great. I think Ayara also will be there. So Andrew, thanks, and it was a pleasure. Recording is still live, and I hope all people in the classroom are enjoying the hands-on.
All right. See you now. Hello? Hello? Arno? Peter?
Yes, I'm here.
All right, so we are back from our lunch, and I think we are ready to continue.
Okay.
Yeah.
I'm logged out of the desktop machine. You need to log me in again. Andrew?
All right, that's
You're doing it. Okay.
So do you have control?
Yep. So we're going to move on to part 6. Yeah.
Okay.
So this is a very important part of the whole process. This is what makes a node secure. So we're going to be getting a free SSL certificate from a company called Let's Encrypt, who made an effort to, amongst others, to make sure that as many websites in the world or services and so on are using SSL as possible. The basic idea being that all internet traffic should be encrypted, and the more internet traffic that is encrypted, the harder it is for censorship to work. Is the basic rule. So 1 bit of HTTPS traffic, apart from being able to see which site it comes from and where it's going to, the actual content of the traffic in between is unreadable by anybody who doesn't own the private certificates. Or the end browser if it's a website. So this is what we're doing here, and the first thing to check here is that our FQDN variable is still set, and we'll be using, as we get down, an application called certbot. So if you do this echo $FQDN, you should receive the FQDN of the server you're not in. If you do not receive this, then we would need to go back to previous steps. But I am hoping that everybody receives the same result here. Well, the respective result.
Please do an echo of your FQDN and check that the output is that FQDN. Okay, this one's good. Have you done that? Echo your FQDN. Have you done that? Who haven't done?
Everyone's done?
Echo the last time when your FQDN. Who haven't? All right, you can continue.
I'm just checking in. I thought we actually already did this, but anyway. So the next bit is just to copy and paste this. Press enter. And we can see that there is this is just confirming that we have this available in our shells. So assuming that you have the same output, we can move on.
Can we run such a similar output? Are you following? Show how it goes. Show how. 1, 2, 3. Ciao, quindi appunto i atti Spotify da rivolto funzione. Now we are together. All right, let's continue, Peter. Peter, let's continue.
Sorry. Yes, so this is an important test to see whether we've done everything else correctly in terms of the FQDN. So yeah, it's just copy paste again, drop in there and press enter, and hopefully you should receive a message saying, yeah, so everything has been done, congratulations. You should receive, if you've got this message, that means that everything was successful.
Are you getting the message? Yeah. All right, Peter, let's continue.
Okay.
Yeah.
Okay, and now we've got the certificates, and it's checked that the node responds in the right place. So now, in order to be able to actually use the certificates, we need to copy them into the system, into the certificate store, and that's what we're doing with the next line here. So again, just copy and paste. So now it's been copied into this path here. And then if we run this line next, it will update the certificate store, and we should see a message saying 1 added.
One added. Everyone added the certificates. Let's follow the right path.
So has everybody achieved this 1 added?
We have an error with node 004 at the certificate section.
Peter, I think you can just run the command again and see what error it returns.
Yeah, what is the error that is being shown? Where is at which point is the error being shown? Is it up here on generating the certificate or copying?
Let me confirm just a minute. It's at the requesting the certificate phase, and the error is the request message was malformed.
So I think that's the environment variable.
Yeah. So I'd say the FQDN has not been set. So if we go back, we need to test here.
Do you do echo FQDN? What do you do?
For node 4, that should look like it should return. It should look like that when you. If it does not, then we can just type it in. And
So after the echo, the output starts with root at. Are you using an apple?
yeah, so when he copied it, he copied the root bit as well. So when he copied from the login, wherever it is, I'm guessing. Yeah, so basically you just need to do it again. So type FQDN equals, and just get rid of the root at. Just take the bit after root at. And then highlight it here and right click. I can also do this for him if you want, just so we can move on. Okay, that's now done for that server. So it just needs to run the certificate thing again. This wherever we are. Just needs to run this command again now. Andrew? It just needs to run this command. I've set the fqdn variable.
Hey Peter, we can continue.
Okay.
Yeah.
So once we've done this update CA certificates, we move on to, so now we need to tell the Zend process, the Zen daemon, which certificates to use, when to validate, to start using the certificates, and to also, yeah, basically. So we're just copying and pasting this again. And press enter. Also here. Here we're adding the user to the SSL cert group, which will allow us to do updates later on to the certificate. Again, this one is changing the ownership of the various files, which allows us to manipulate them later when we need to update them. Again, just copy and paste. And this one is starting a new shell just so that the environment variables get loaded. Again, oops. Like so. So now we should have the certificate loaded at this point. We just haven't loaded it into Zen yet. And this here will allow us to do that. So this will stop Zen, tell it to sleep for a little while. It's important to let it sleep because closing the databases and the wallet file is necessary before reopening. Otherwise, it will get corrupted. And so, yeah, we just need to stop it, wait for a few seconds, and then start it again. So just for reference, the and here means, do this command, then do this command, and then do this command. You can also use semicolon. Okay, so now we see Zen server is stopping. Now it's sleeping for 5 seconds, and now it's starting it again. To verify that the certificate is being loaded correctly, we can have a look at the network info, as we did earlier. And now we can see TLS certified, cert verified, true, which means we've successfully loaded the certificate in, and the Zen daemon is using the certificate. So that is pretty much the hardest bit of installation done. Now we need to do some things around making sure we have enough Zen and so on. Is everybody up to that part? Uh-oh. Okay, I see somebody has a problem with node 28. Let me just have a look quickly at this. Oh, it seems we're having internet connection problems.
Peter, 28 was mine.
Hmm?
I'm saying node 28 was mine, and you said you can later.
Ah, okay.
Yeah.
I'd also like to check out node 008.
Okay, I don't. It seems like TeamViewer has crashed. Let me just try again. I think there was an internet problem briefly. Okay. Oh, now I'm connected twice. Great. Node. Oh, oops. 08. Oh. Password again, please. Andrew. What's the problem with 08?
Just a minute.
Ah.
Okay.
Yeah,
Hello.
I can see what the problem is.
Hello.
Yes?
Okay, so my problem is I'm trying to stop then restart the Zen, but it's not working.
Okay. But I can see also there's a problem here with too many certificate paths in here. Oh, then you just need to start Zend. Hello?
Hello?
Yeah, you just need to start Zen.
Yeah, I've already started it.
Okay.
We also have another error.
Hi, Peter.
Hey.
I have an error on node 6. The TLS certificate is, I keep getting it false.
Okay. Let's have a look.
Get info. Mali amestop.
Oops. Okay, it seems you've changed the root password on this node.
Yeah. Wow. Root password. When did I change it? Try it.
I can change it back. It's okay. I'll do this.
No, false TLS. Misha. Into that.
Try this again. I changed it. Let's see. Okay. We got a lot of different. We got this in 3 times. But this otherwise should be okay.
Oh, hi, Peter.
Hi. Hi.
Hello.
Hi.
Oh, I'm trying to run the 9th command, but it's
Okay.
bringing an output of it's not connecting to the server.
Okay. Let me just fix this one up first, and then I will get to you. I don't know what password you set there.
It's not 7.
Hmm?
Password is same as username.
Same as what?
As a username.
Me.
No.
Apa hivi?
Why is it not appearing?
Can you check the Let's Encrypt folder? Is it definitely there?
This bit is, I don't know about. Huh? It's there. But there's no certificate appearing. Yep. Maybe it's already installed. It looks correct, right?
You restarted Zen, yeah?
Yeah. In general, I would say that's
Just
the
you're definitely running You're definitely running Zend under the user. Oh yeah.
yeah, it is. But I don't see the certificate being added anywhere. Like the roots, or the intermediate or whatever. Which is a bit strange.
Oh, okay, so we could give them one of the standby nodes that Nate has done, or ask them to double up.
User share CA certificates, or is it user share extra? What's the thing again?
What do you copy it to?
Yeah.
User local share.
User local share, right? I'm just looking in the backend. User local. The chain cert is there. Why is it not loaded? Okay. I don't know what the password is though.
Password is Mimi.
Our password is Mimi. Okay. But it's just not adding them.
Yeah, strange. Let's leave this one and move on, I think.
I guess we can move on because of time.
Yeah.
Right? Then we can figure that out later.
Yeah, we have some other nodes set up already in case, or not fully set up, but which ones are they, Nate? There's
Is there anyone else with an error? Anyone else with an error?
so
24, 25, 26.
yeah. If you take any of let's see, Notepad, where are we? Oops. Oops. Any of those ones can be taken by somebody else, and the password is just password. So this is the user here, if you want to follow on. Nate, where are they up to? Those ones?
They should be good to start on page or part 7.
Part 7, okay, from the very start. Yeah. But this has already been done, right? The FQDN has been set.
Yeah, the cert, everything's valid. You can. I just grepped the TLS. It's true.
Ah, Okay, they've already been done, all of this. Yes?
Yes, that's correct.
Okay. So, yeah, I see. I thought we were into part 7 already. So anybody who's not been able to get there so far, please, amongst yourself, pick one. So we're not all up on the same one. And any of these ones can be used, 13, 17, 24, 25, 26. You can log into them with this username, ZenOps, and the password is password to continue part 7. Okay?
Okay.
So we move to part 7. I leave this up so people can see it. Where can I put it? Okay, and at this point, I think we're going to, well, we need to get, I guess,
Do we need my desktop up?
Yeah, but we need this at least.
Yeah, that's right.
So, first thing I'm going to do on mine, and you guys should do on yours as well, is to run this command here. And so what are we doing in this step? Well, we need a new address on your node so that we can send some money to it to fund the node. You know?
So just worth pointing out. So you will see on step 7, we have the first 2 steps are to install a wallet, which is called Horizon. Horizon is a light wallet, which means it doesn't have a full copy of the blockchain downloaded, and it doesn't support sending to a private address, a Z address. So the guide takes you through installing Horizon and then using a T address, which is a non-private address, if you will, on the secure node. And you'll then use the secure node to send that balance to 2 Z addresses, which are the private addresses on the secure node. And that balance is then used to fulfill the challenge request. So unfortunately, you won't be able to do steps 1 and 2. We're going to demo now steps 3 through to the end, just to show you how that's done on testnet.
Yeah. So the first thing I'm going to do here is run this part here. I'm going to get a new address, and the immediate output is an address, which I'm going to copy for Paul. And then we're going to switch over to Paul's computer. Oh, wait, you want the second one, right? Oh, no, it doesn't matter. Which one do you want?
No, yeah, run the second command as number 4. So the purpose of steps 3 and 4 is to avoid using a T address on the node, which is currently used as a unique identifier for the node. So what Peter's doing now is he's just confirming that the address just generated is the second one on the secure node. And it is. That's good.
Okay, so I posted it in our Discord.
Yeah, I've got that. I just need to share my screen now.
Yeah, I'll just stop sharing. No, where am I? Here.
Huh?
Okay, excellent. Right, okay, so what you're looking at the moment is a testnet explorer. This has been built specifically for the demo. And as we showed you the mainnet explorer earlier on, and the purpose really of having this is the Insight suite of products allows you to not only install an explorer, but also an API. And the way the Horizon wallet works is it communicates with the Insight API, and via that it broadcasts the transaction to the ZenCash network. So I'm just going to put that to the side of the screen. Can you hear me okay?
Yeah, I just muted them because of the echo.
Okay, now we've built a specific version of the Horizon wallet to run the demo. As you can see here, it's called Testnet Local. This is a specific build that not only talks to testnet, but also talks to my own testnet explorer and API, which I've got shown on the right-hand side of the screen. So I'm just going to log in. And as you can see, I have 3 different T addresses already present in Horizon on the left-hand side here. Now, there are 2 balance requirements for running a secure node. The first is that you have a stake address with a minimum balance of 42 Zen. This one's a good example of that. And the second requirement is to have a small balance. We're going to use just under 0.05 Zen on the secure node itself in the private addresses in order to pay for, if you will, the challenges. Now, I have the address that Peter generated from his secure node, and what I'm going to do is I'm going to use a feature within Horizon called batch withdrawal to remove or withdraw the 0.05 from this address here and send it to the secure node. The convenient part of using batch withdrawal is it means I can use this address as my stake address, because the 42 Zen will remain in that address when I perform the batch withdrawal. Anyway, enough talking. Let's have a quick look and see how that works. So I just clicked on batch withdrawal at the top there. And I'm going to select the address that has 42.05. And have a look. I'm going to use the address that Peter generated on his secure node, which is this one, starting ZTNW and ending IJ1L. And as you can see here, the Horizon wallet is specifically targeted for people who are running secure nodes, because it defaults to having an amount to keep in the address selected of 42. And by doing that, it means that your stake address never drops below the required balance to run a secure node. Now, this should have happened fairly quickly, and we should, if I'm just going to quickly refresh my Insight. As soon as I click on withdraw here, we should see the transaction appear on the right-hand side in the testnet block explorer. So I click on withdraw, click on OK.
Murphy's Law.
Yeah, this is a good example of Murphy's Law, isn't it? Here we go. Excellent. So you can see the transaction has been sent across to the API. Now, what you can also see is that actually the value out shows us 42.0499, and that's because what the batch withdrawal is doing is it's actually creating 2 transactions. What it does is it returns the 42 Zen back to the address that we sent it from, which is this address here, and the other 0.05 minus a transaction fee will be sent to the T address that we just sent the transaction to, so onto Peter's secure node. Now, it takes a couple of minutes for the transaction to complete. initially it will show as unconfirmed as a withdrawal, and then as soon as the transaction is included in a block, it will move to confirmed, and we should be able to see the balance on Peter's secure node, and we'll see the balance updated within the Arisen wallet.
Andrew, you're muted, just by the way, in case you want to ask a question.
Peter can continue.
Okay, so there's no questions about this because this is a fairly crucial part of blockchain technology. What's actually happening now is the block is being mined. So actually, Nate's probably the only miner on there at the moment, and he has a machine that's doing calculations and trying to find two very large prime numbers in general. And once he finds them and receives a block, then the transaction can be included. And there you go, it just happened. And probably we can see that this was, in fact, Nate. Let's have a look. If we click on the block.
So yeah, hopefully you just saw that on screen. So the balance is now returned, has reduced to 42 exactly on this graph. And that was obviously done because the block was generated, which included our transaction. So I think, Peter, shall I stop sharing and let you check on the node?
Yep. So I will present now. Wait. Sorry. Let's go from here, huh? Okay. So some Zen has been sent, and if we have a look at you see now that we have a balance of 0.0499, which is what was sent. So that has all worked out as it should have done. And this, then we can move on to the next part. Did you want to send some more, Paul, to other people so they can see it? Or
I can, yes. If you're able to gather some addresses, I'm more than happy to send some more through. I can do that.
Do we have more staking addresses as well? Andrew, how are we doing for time? Because the next part could take a while if we have to get everybody doing it, and it might just be easier just to, or better just to demonstrate it.
So we have the lab for another hour.
Okay.
But as for timings for the training, we were supposed to be done by 3, which I think it's now 3. But
Okay.
I'm guessing, guys, are you guys flexible? You'll be here for the next hour. So I'm guessing we have an hour.
Okay.
So I think as I haven't got a number of stake addresses prepared, certainly not enough for the entire session, perhaps we demonstrate the next few sections, Peter.
Yeah.
So it will be better if you demonstrate for us.
Yeah. So the next part that we're doing is basically to register the node now. So we've got to transfer some of this money to 2 private addresses and so on. But we can just go through and do this. So we've done this bit. We've seen that the balance has appeared, and now we have a long. Why can't I? So many buttons. Okay. So now we're going to generate 2 we're going to generate inside this command. What we're going to do is generate 2 private addresses because we need a private address to perform the challenges that are required. And we need to send money to it. So we have a single line that does this. And to break this down quite quickly, this is saying ZenCli send some money using the first address, the address that this was sent to, which is this address. That's what this part here is. You can see it's the same command as written there. And then we're saying generate 2 new addresses. So this is get, and when you use these Z commands, this always relates to the shielded addresses. So we got Z get new address, and we're doing this twice. And in both cases, it will send money to it. Oh yeah, this should be enough. Yeah. Okay, so I'm just going to copy this, and now I am sending. I'm just copying that across, and when I click enter, I get this operations ID, and we should see once the block has been mined or the transaction has been included in a block. You can see at the moment all the money is in the transparent address, and we need it to move across to being in the private address, which is what happened when the transaction goes through. So we should see this watch is running every 30 seconds, and will update every 30 seconds. I might actually change this so that it does it quicker. So every 2 seconds, it's running the same command. And we should see, as soon as the transaction gets mined and the block is received by the node, we should see the amount switch over from being in the transparent account over to the private balance. Any moment now.
Hey, Peter.
Yes?
How do we get 42 cents to our written wallet?
How do we get 42 Zen?
To our written wallet.
Well, I mean, in the real world, you usually buy it. If you have a lot of mining equipment, you could mine it, but I think it would take you quite a long time to get to 42 Zen. You'd have to find a block by yourself 4 times, effectively, which would be quite rare. Or yeah, you buy it from an exchange, like, well, we're listed on quite a lot of exchanges now, but the 2 largest ones are Binance, which is in China. That's the largest one we just got. It's the largest in the world, and we just got listed on it. Oh, by the way, just the private, you can see now the amount is now transferred over to the private address, so the transaction's gone through. The other big one is Bittrex, which is a US company, I think. Yeah, so basically you would go on to one of these. You would normally have to, I think on both of those, you cannot use dollars or something. You first have to buy something like usually Bitcoin. You buy Bitcoin first, and then you would use that Bitcoin to buy ZenCash. So I can show you quickly.
I think also Peter will share some of the exchange platforms with the class, yeah?
Yeah, we can do. Yeah, I think it's in some of the presentation material as well.
Yeah.
So like this is Binance, for example, and if we click on the exchange, then I can do a search here for
the ZBTC.
So the Zen is the thing here, and we can see there's Zen. And we can see the current price. So for every Zen is worth 0.002975 BTC. So with 1 BTC you can buy a lot of Zen. Yeah. The current price is, I think, about, oh, there you go, it says $22 US. So to buy
42.
To buy 42, it's 42 times, let's say 2271 is 953 US dollars.
Yeah.
Roughly. So you need a little bit more. So let's say it's, I don't know, $970 you would need US to run a secure node at the moment. You need a little bit more for the challenges. So, right. Yeah, and so that's basically how that all works. So the next step here to explain, I mean, there's another video here to explain what the challenge response is all about and why we need money inside this private address. If you want, you can look at this. I'm not going to press play now, but this is again BlockOps or Rolf, who is one of the co-founders of the cryptocurrency. Okay, so the next part of the thing is to install the tracker. So this is how we can register to the oh, I'm gonna write this thing in. Oh. We're installing Node.js. And we're getting the latest version of it. Did it do that? Can't see. I think it did. Okay, so now it's downloading the latest version of Node.js. I'm going to make a directory for the tracker, and then we're going to clone the code for the tracker into another directory. Receive the file. We're going to go into there, and then we're going to install it using Node.js. So this npm install will look into the description of the application. It will see there are some dependencies, so other libraries and so on that are needed to run it, and it will download those as well. It's the same for every node application. This step is likely to not be necessary in the future because we're planning to build the tracker into the Zend process, but for now it's still required that we do it this way. So now we're going to run the setup. And so we need our transparent staking address, which Paul has sent me. I'm going to put in here an email address. So in case any of you want to contact me, you can always send me an email here. So this is the official email domain for ZenCash, and all of us have email addresses usually with our first name. I think so far we have no collisions on first names, which is rare. And then we want to put in the domain name for this domain, which is, let's see if I can find it where I've written it somewhere. Here somewhere. Yeah. It's always safer to copy things if you can, because you don't have mistakes. Now we're using IPv6, so the answer for this question is to use 6. And this just runs some code in the background to ensure that domain resolution and so on happens properly. We're also in Europe. We have 2 clusters of servers. We have 4 servers, 4 tracking servers in Europe and 4 tracking servers in North America. This server is in EU, so I'm going to enter EU here. And Then we're done. Oh, I think I need to also I need to change this to run on testnet. So this is a step that you wouldn't have to do if you were running your node on the mainnet. And where have you put it? I don't suppose you pinned that one also. Yeah, there it is. Okay. Yep. Okay, I'm going to save that and run again. Does this matter? I haven't done this before on the... Let's see what happens. And now, finally, we're going to register this node, or this secure node, onto the tracker server, and we can see here. There you go. It's waiting to register. Now the registration is successful. So we should actually see it do a challenge soon. I'm just going to go to the tracking site for this, which is not this one. And we should be able to see as soon as it loads. And there we are. We have our node registered. So yeah, so that's, I mean, you can see there's not many on testnet. There will be some more in the near future because we're getting a new version of the software, so there will be a lot more people on there soon. But at the moment, you can see this is the ZenCash training one, which I just registered. So this is number 30. So within this site, you can see the main things. But if you actually click on the link for your node, you can see a whole heap of other information. So you can see what sort of exceptions there were. You can see a general errors. So if the Zend is down or sys is down, or if there are too many reconnects within a short period of time, which is an interesting one. I haven't seen that one before. And various other errors here. So you have when challenge doesn't complete, or if you took too long to run the challenge, or if your staking address doesn't have 42 Zen in it, or if they're unable to figure it out, or if you've tried to duplicate your stake, so try and use it in two places at the same time, which is obviously would not be good because then you'd be rewarded twice for one stake. If your certificate has an error, if your peers if you don't have enough node connections or connections to other nodes, if your blockchain is not up to date, if your version of Zen is out of date, if your version of the tracking software is out of date, if you don't have enough balance in your node to run challenges, it will also tell you, and also if you've duplicated an IP address with another one. There are two further sections in here. We have the challenge results, which currently we don't have a challenge. I can send one in a second just so you can see what that looks like. And you can also see your payments as well. I can show you on the mainnet what this looks like for a real node. But let me, oh, I don't have any button here. Why is there no button to send challenges? It should send one, but let's have a look on the real one so you can see what a real node looks like. No doubt I'll pick the worst possible one from my nodes. Let's see. Oh, no, SA. So this is one of the nodes that I run for somebody else. And you can see we have a bunch of small errors here, some here as well, some longer ones where a challenge was too long or wasn't received properly, or where the stake was removed accidentally. And you can see, for example, some challenge results. So how long did it take? So it's 45 seconds to run a challenge, which is the total, the maximum amount is 300, so it's quite fast. And you can see some of the payments as well. So you can see not enormous amounts of money, but some amounts here based upon the amount of uptime that the node had. So that's basically it. And if we go back, now there's some other things to follow up with. So now we're registered, we're on there, we can see what it's doing there. But if we just run it with node app.js, then it will close afterwards. So it's not a static service that can be just left. It will close as soon as I press Control-C here. It's no longer running anymore. So we need something that keeps it running all the time. Yeah. So the idea is we set up two services. The first one here is a service that makes sure that the Zen daemon that we installed previously stays up. And the second one is for the Zen tracker service. And here we also just copying and pasting in. These are creating two service files that then need to be copied, which is what we're doing here. Copying them into systemd. And we're stopping Zend so that we can start it properly using the services. So there's the tracker and Zend, and now we can see the status of them as well. So we can see that they're both running. Yeah, it just gives you a little bit of information. If there was some problem with running it, then this would obviously turn red, and you would have some indication of maybe what was wrong, and be able to do some debugging. But in general, it's now ready. You can see a little bit more information by looking at the log files for the Zen track. Oops. So you can have a look at the log files here. So this is there you go. It's executing a challenge right now. So you can see, let me just expand this out. So you can see it's now taken 40 seconds to run a challenge. It shouldn't take too long because the node is quite empty, or the server is quite empty. It's a bit like watching paint dry, so I don't tend to stick around while I'm watching challenges, but the first one's always fun to see how fast it's executing and so on. And here we go. We've submitted. We finished in about 110 seconds, or 114 seconds. We've sent the challenge result off to the tracking server. It's been received, and we've received a reply back saying the message has been received. And now, if we went back onto the closed the wrong one. If we go back here, and click on the testnet server, we should now see here. I don't know why it's not showing now. We should now see challenge results in this box. Something must be up with it. I'm not exactly sure what, but normally you would see the challenge results here straight away. It updates immediately. Yeah, so that's that part, I think. And the last bit is just to enable it so that it restarts on startup. So we just run this, and we can now see that there's been a symlink added into system D, such that the services will now be restarted when you reboot the node, for example, which keeps it running. Okay, part 10, I think, is right. So the thing with the certificates that we configured earlier is that they time out every 3 months. And this is obviously not so helpful. And what we would actually like to do is that there should be a job for this that automatically renews from the certbot service, and it should, when it renews the certificate, if it's run, then it should restart Zen so that the new certificate is being used. So we're just installing this as well. This pretty much the same as the last one. Now we have the daemon reload. And if we look at the timers now, we can see that indeed there are 3 timers listed, and I'm not sure why I can't see which ones they are. Maybe I have to expand it. Right, there you can see that there was a certbot timer there. So it passed 5 minutes ago, and it will run every, what is it, every 5 minutes or something? Something like that. And now finally what we would do is reboot the server, log back in again, and ensure that everything is still running. So that's pretty much it. That's the end of the tutorial. I'm sorry we couldn't go through the whole way through everything. This guide isn't really designed for people who are planning to set up a mainnet one. I think we need to refine our training materials and have better setup to be able to get everybody registered within testnet. But this was our first run through with the new guide with such a group. So thank you for having the patience to run through it with us. Yeah, but that's pretty much it from me.
Unless we have any questions from the class.
Unless you have any questions, of course.
Yeah.
Hello.
Yes.
Are there any questions?
Yes.
Sir.
Could you show us how you calculate the rewards of a secure
Sure.
node?
So there are a couple of calculators out there. Sorry, yeah, there's a couple of calculators out there. This is the main one that we use. So basically, you can see 3.5% is for secure nodes. Hello, can you hear me?
Yes.
Okay. So basically, you can calculate how many secure nodes are there. So if we look at this website, the main nodes website, we can see, for example, that globally there are about 12,000 nodes, and 11,195 are currently up. So if we assume that 100% of those would qualify for payments, then we can put that number in here. The price of Zen at the moment, as we saw before on Binance, is 22.71. So we can put that in. It does say USD here, but you could calculate it in whatever. It doesn't really need to be USD. It could be Euro or whatever. So as long as these two values are relatively in the same currency, it could be either. So let's say a VPS in US dollars costs you $8 US, and then we can click calculate, and you can see that the total value at the moment is $15.44, and your monthly profit is $7.44. I mean, our price has taken a dramatic hit recently. It was up at about $50. If you put that in, then you can see, you're making about $26 a month in profit. And overall, every year you'd be making about 14% or so ROI. Of course, this is about to go up to 10%. So there's a newer one called... wait, I've got it on my computer. Let me just check.
Tomato sini hiyo nini? Sina zile tomato fresh.
So let's say we have created one, and we use the same number, 1195. So we're about to have an upgrade so that the 10% of earnings are returned. So now we have exactly the same calculator, but with 10% coming back. So the value of Zen is the same, 27, like this. Monthly costs are 8. And so this is from next month. Somewhere towards the end of next month, this will be valid. So here now you can see you're now making, even at the current prices, you're making $43 a month from this. So your monthly profit is $35, and likely there will be less nodes because some of these nodes will be converted into a new class of node called super nodes. So let's say that this halves, which is possible, then you could be making, in profit, $73 a month from one node with no extra cost, right? The profit goes up with no extra cost. It still stays the same, and then of course if the price rises, which is quite likely because it will be more in demand, then you could be looking at up to, I think this is quite realistic that we could be looking at somewhere between $100 and $200 profit per month per node. So I mean your ROI there is 98% within a year. So you're making, but within a year you could buy another node, basically. And of course, this does not exclude you from, for example, trading and various other activities that you can do with that money that you're earning every month.
So are you saying, can you really predict when you can break even?
I mean, there's not really the break-even point is already there because your actual only cost is the cost of the VPS, right?
Okay.
Because the 42 Zen doesn't go anywhere; it still belongs to you. You can always take it out. You can always go and trade it. You can just stop running the node and then stop running the VPS. After 1 month, you've paid your $8 for the VPS. That's really your only cost is your VPS cost, and of course the time that you put into maintaining the node and so on.
Okay, unless 42 Zen went down in value, right?
Of course, yeah. So I mean, this is what I try to say is there's an opportunity cost for tying up your Zen in a stake for a node, but there's no. I mean, even this ROI calculation. I mean, ROI is not really. It's not really that you're investing, There's an opportunity cost, but there's not really an investment. The only investment is the VPS cost. So in fact, from my perspective, the ROI is a couple of days. Generally speaking, I mean, I also host nodes for people. Mine cost about €6 each per month. And generally the first 7 days of the month go for the VPS cost. And then the last 3 weeks essentially are profit from that node. So, you know, from my perspective, ROI is actually 7 days every month. But of course, if you want to have another node, if you want to have more stake, then the return, which adds up to that, is about 1 year. In this case, yeah.
Okay, Peter.
Mm-hmm.
My question is, after you've downloaded the Arisen app, when you go to the batch withdrawal, you're supposed to like enter like a transaction code. We got 2 addresses code, but entering both of them, nothing happens. What do you do?
Okay, I don't know what was sent there. Paul, would you like to comment? What was these 2 other addresses? If Paul's still there. Where did these addresses come from?
Like
Sorry, go ahead.
Go ahead, explain. Well,
Hello?
yes.
How can I? What was the question? I didn't understand. You had 2 addresses. Where were they from?
Yeah, like in part 8, Peter.
Yes, I'm there.
In part 8, you're supposed like after downloading the Arisen app, you're supposed to enter like 2 addresses. The first address you got is for the transaction to your secure node. Then the second address was to link it to it's like your transaction code. Like if you wanna trade it with somebody or something. So I was asking.
Okay. Let me get back there, and then we can.
Yeah, sure.
In part, I think it's in the part 7. Is it?
No, part 8. Yeah.
This one. Yeah.
Yeah.
Right. Let me just expand this out so we can. Okay. So yeah. So when your node starts up, it has 1 address already.
Yeah.
And then we want to create a second address. The reason why we do this is we have another wallet called Swing, yeah, and Swing is a full node wallet. So it runs the same software as your secure node, but the difference between it and Arisen is that it can send private transactions, but Arisen can't. On the other hand, to sync up Swing takes 24 hours or more to download the blockchain and have everything running, yeah.
Okay.
So we developed this other method where you create a second address on your node, and then you send some money to that second address, and then you use the node itself to distribute the money out to the 2 private addresses inside the node that are required for the challenges. I don't know if I'm explaining this well.
Yeah.
Let me just so okay, so we've got Arisen here. Huh? But Arisen is just a thin client, effectively. Yeah. We have another one, Swing, and Swing has a database. It has the blockchain, effectively. Where's the thing here? Yeah, it's a full node. So the Swing operates with a blockchain, so it can do everything that a full node can do. It can send private transactions and so on. Arizen, by default, can only send T. Where are we? Let's insert a. Oops, there it was. Ay. So Arizen can send T or public transactions. No? Whereas Swing can send Z transactions, private or shielded transactions. Yeah. So then we have our nodes, which are out here. Secure node has the blockchain as well. It obviously has the same capabilities here. And a challenge what's going on here?
The difference here, T and Z. T is public.
Yeah, a T address is like Bitcoin. Yeah, Bitcoin has. In fact, that's the reason why it's like Bitcoin is because they are exactly like Bitcoin's addresses. ZCash comes from Bitcoin originally, with then ZCash. So ZCash, which is like an ancestor of ZenCash, took the Bitcoin code and added privacy to it. Yeah, so this is when then became ZCash. And then Z Classic came out of ZCash, and then ZenCash came from Z Classic. It's a fork of a fork of a fork, yeah, or a fork of a clone, a fork of a fork of a clone, effectively. So yeah. So these T addresses are exactly the same as in Bitcoin. Like the code is the same, everything's the same there. The whole way the blockchain works there. These are special. The private shielded TXs. Bitcoin does not have this. Bitcoin is pseudonymous, it's not anonymous. Yeah, you can track people down through the blockchain. So the problem that we have when we're doing this is that if you want to download this, I mean, where's my boxes now? This is when I need it. Shapes. So a challenge is actually a Z transaction, right? And so the way that it works is that we have some Z addresses inside the secure node, and we need to fund these Z addresses in order to do the challenges, right? Let me just put this in. What is going on?
When you want to transact, after you have two addresses. They first address the private one for the Z. It's like doing what? It's like encrypting what you're transacting. The second one is used to link you and one the person you're transacting to. So the person only sees the second transaction, not this one. So that one will be public.
So yeah. So what we're trying to do is Arizen can't send money to Z addresses. Yeah, it can only send public transactions. So what we're actually doing is we're sending from Arizen to an address, a T address, on the secure node, and then we're using the secure node itself to send transactions to the Z address, which allows us to do the challenges. We could also download Swing Wallet, right? This is what I have at home. I use both, in fact, because I host a lot of nodes, so it's much easier for me if I can send directly. So I use the Swing Wallet to send transactions to Z addresses on the node, and I use Arizen for most other things, basically. Did that clear it up at all?
It's clear.
Yeah?
That's clear.
Just so you know, the way that Arizen works, the reason why it can be so light, it's such a small application, you just download it, you don't need a blockchain or whatever, is because, in fact, what it's doing is it's connecting to a node. Every time it sends any transaction, even a public transaction, it's creating the index. It does it's so-called transaction hash. Yeah, so you can use any. It's just code at the end of the day. You just need to know the parameters. You can build a transaction, and as a JSON file, essentially a collection of data, and broadcast that data out to the network. And as long as it's been signed by the correct private keys and so on for the address that you're trying to send money, you can broadcast this to another node and say, can you please send this out to everybody, and put it into the mempool, which the mempool is a collection of all possible transactions, or all transactions that have been submitted. And that's how it works. That's how it can. So it doesn't have its own blockchain, but it can rely upon the fact that all the nodes have a copy of the blockchain. So it makes it much easier, and it's only really a technical consideration that it cannot do Z transactions. And in fact, the new version of Arizen, you can connect directly to a secure node and also send private transactions as well. But you need a secure node first, or you need a node first that's on the network.
So, Peter. So the 42 Zen will stay in your wallet, right?
Yeah, it would stay on this side of the fence. Yeah, you don't want to put the 42 onto the secure node.
And you need to allocate the other Zen for the challenges. So that stays in the node itself?
Yeah, it's just a small amount. I mean, I send 0.04 Zen. So I think it's, I don't know, it's not very much. It's maybe $1 or something like that. It's not very much at all.
Okay.
Yeah.
Okay.
So if the node gets compromised, I mean, I run about 800 nodes. So of course, if it's $1 on each one, then it's $800. So it's not insignificant, but it would really take that somebody compromises all 800 nodes to be able to make that sort of money. So we tend to recommend that you put a small amount as possible on there, with the recognition that, of course, if you put less and less and less on there, that at some point in the near future, if you put a tiny amount on, you might need to come back and put more in. As long as you're prepared to do that, then you can get away with putting very little on there.
Okay. Okay, thank you. And
Okay, guys, any more questions? Yes? Just wait. Or can you access multiple nodes in a single node?
like, I think it just means you have a second node. If you have to like make another one.
Okay. Okay. Peter. Hello.
Yeah, the computer was trying to shut down. I don't know why.
Hello.
Yeah, I'm here.
All right. So if you have multiple nodes, do you also need multiple wallets? Or you can access...
No. You need multiple addresses, but those addresses can be in one wallet. So each wallet, like one Arizen running, can have an unlimited amount of addresses in it. You only need one address. There's a crucial distinction there. This is a wallet. Both of these have wallets, including your secure node, but inside you can have hundreds and hundreds and hundreds of addresses, and you only need one address with 42 Zen in it per secure node.
Okay. All right. I guess that's it, right? Okay, Peter.
Okay.
Yeah, so
I know it was long. I know it was long, but we got there in the end, sort of.
yeah, sure thing. I believe we.
And thank you for being the first group, because you're the very first group that we've done this training from. So we've learned a lot about what goes wrong and how we can make it better for people in the future. So sorry if it wasn't as polished as you might expect, but this is literally the first one. So.
No worries. We are even looking forward to hosting other trainings.
Yeah. I've been talking to Arno about even coming to Kenya and doing it in person, because I think it's a bit hard for me to or for any of us to debug technical problems and so on from when we can't even see the screen and so on. It's quite difficult.
Yeah.
We've also learned a lot as iLab Africa Strathmore as the hosts, such as connectivity and troubleshooting the computers and availing also the participants. Because you realize blockchain is a technology that is really buzzing right now in Kenya. Because for the applicants, we had over 80 applicants in less than an hour. We had to shut down the link.
Yeah.
Yeah, so basically we can, when you guys are planning to come over, we can even plan for a forum where
sure
you guys can have a full session with around 300 people. Yeah, in one sitting.
Yeah, I mean, you should also, I mean, if people are interested in getting involved in ZenCash, even if you're not buying or whatever, you just want to come and see what the community is like. We have a Discord channel that I think it was shared already, and there's thousands of people in there. I'm on there. All of the people that have been in this meeting are on there, and we talk and we support people in there, and and so on. And we also have this official ZenCash support place. So yeah, just come along and say hello.
Also, Peter, I'll share an email with Andrew, and then they can the presentation also, and it can be shared to the class.
Sure.
At least with the links on how they can find us on Discord.
Yeah.
And all that. Yeah.
I believe that will be good. Thanks, Hugh. Thanks, Peter. Thanks, Nate, and Arno, everybody for joining.
Yeah.
Thank you very much. Have a nice day.
Yeah.
Thank you so much. All right. See you guys.
Okay. Have a good day. Thank you.
Yeah. Have a nice weekend.
Yeah. You too.